Good afternoon, everyone. My name is Mizanur Rahman. I am a recent graduate from the Department of Geoinformatics for Urbanized Society at University of Tartu. And currently, I am staying in the United States. I am doing another master's in the Department of Geography at Western Michigan University. And today, I will be talking about my thesis that I presented for University of Tartu. Can you start with the presentation?
Should be possible for you to change the slides.
Yeah. The topic today, I will be talking about the algorithm development for measuring CDOM and Secchi from Hue Angle using satellite images. And this study was done in Lake Peipsi, Estonia. And this study was supervised by Dr. Krista, Abbe Ansper Thomsalo, and Dr. Raibon. Let's begin with the understanding of water transparency and CDOM. So the water transparency reflects the clarity and purity of water, indicating the light penetration level. It is a critical measure for water quality, which is influenced by various factors like particulate matter or other dissolved substances. And Secchi depth is a traditional quantitative method that is used to measure water transparency, and it involves it involves submerging a white disk in the water until it becomes invisible. And the CDOM stands for color dissolved organic matter. And CDOM resulting from degradation of marine organism, and it colors ranges from yellow to brown. It significantly affects light absorption, and especially blue and ultraviolet spectrum, which alter the water transparency. CDOM is a vital indicator of water quality that contributing dissolved organic carbon or potentially the eutrophication. On the right side of the image, you can see visually how by using Secchi depth water transparency is being measured. Watercolor provides a valuable insight into the ecological and chemical status of the water body, and watercolor is being influenced by various substances present in the water. Watercolor generally from brown to yellowish, which indicates that there is a high amount of CDOM. There is a high amount of CDOM in the water. And I also want to introduce Hue Angle, which is a metric that is derived from color theory and representing the dominant wavelength in color in a circular format. The Hue Angle is calculated from chromaticity coordinates of water samples obtained through spectrum analysis. By analyzing Hue Angle, the concentration of these substances is measured the color characteristics. On the right side of the image, you can see there is a color space where you can see how the Hue Angle is measured. So the remote sensing sensor capture watercolor through captures watercolor, and each color has a certain position in the light in the color space. So if we know the position of the position of watercolor in the color space, we can calculate the Hue angle, and by using the Hue angle, we can estimate the amount of other substances such as CDOM and Secchi depth in water. There are various environmental factors that influence watercolor and Hue angle. Uh, CDOM wind speed, wave height, cloudiness, cloudiness, etc. Influences watercolor. Cloudiness and sunlight particularly influence the satellite image collection, and the satellite image such as the cloudy and poor sunlight can be a reason of poor satellite images, and which can influence the quality of a research. We can use remote sensing technology for water quality assessment. The traditional water quality monitoring method is collecting in situ data by going to the field and take samples, and going to the lab and analysis. But this method is often hampered because of high cost, extreme weather event, or inaccessibility, or sometimes inaccessibility to the water. In Estonia, particularly, the extreme cold can be an obstacle for collecting for water quality monitoring. In this case, the remote sensing technology, particularly satellite imagery, is being used and a promising technology to assess the water quality indicators such as CDOM or water transparency. It enables examining water quality changes over time and across different region, and it is particularly useful for monitoring large water bodies like Lake Peipsi. But developing an algorithm to measure water quality is difficult, particularly for Estonia, because Estonian lake represent unique ecosystem, but there is yet the comprehensive research on water transparency and CDOM is lacking. This gap may result in incomplete understanding of pollution or environmental stressors. In addition, case 2 and case 1 water shows distinct property, and case 2 water, which is optically complex, and the algorithm, the development for the case 2 water is complicated. Lake Peipsi represent the Lake Peipsi has the case 2 water, which is optically complex, and development algorithm for Lake Peipsi is challenging. The objective of my research was algorithm development for water transparency and CDOM from estimated color index based on field data, and secondly, applying this algorithm in remote sensing data to derive transparency and CDOM amount in water, and to see the seasonal analysis on these parameters. This is the study area of study area of my research. And Lake Peipsi consists of three parts, but as a whole, it called Lake Peipsi. And you can see there are 23 stations, 23 stations from which in-situ data such as data of CDOM or CDOM, Secchi, or water depth is being collected by Tartu Observatory. And if we analyze the general overview of Lake Peipsi, in winter time, there is limited water circulation in Lake Peipsi due to ice cover, and in summertime the water temperature is approximately 20 degrees Celsius, and there is water quality varied across the Lake Peipsi. The materials and method used in this study was collected from Tartu Observatory, and the data collection period is from 2016 to 2023. In the right side, you can see there just a snapshot how the data was looked like when I used. So there was data of cloudiness, wind speed, Secchi depth, water depth, chlorophyll and CDOM was in the data which I used for the further analysis. Satellite data was acquired from 2016 to 2023, which ensures and comprehensive temporal coverage. And Sentinel data was collected from EstHub, and the processing tool used by EstHub was Polymer version 4.16. And I also collected matchup data from EstHub from 2016 to 2023, focusing on mostly on cloud-free data. And the data measurement was aligned with the satellite overpasses on the same day. And I filtered the data using CloudFlux 0 and 1024. CloudFlux 0 indicates that there was no error in the sensor while the satellite data was collected, and CloudFlux 1024 indicates that the data was poorly collected from the data used was purely collected from water body. And I collected the data which has pixel value 1 meter by 1 meter, which ensures the detailed water quality assessment. And the methodology used in this research was getting first of all getting remote sensing reflectance data from EstHub, and using this in-situ data and remote sensing reflectance data, an algorithm was applied to calculate Hue Angle. And then I find out the relationship between Hue Angle, CDOM, and Secchi depth under various environmental conditions. As I already told you that environmental condition, various environmental factors influence Hue Angle. And under all these environmental factors, I find out the relationship between Hue Angle, CDOM, and Secchi depth, and which was expressed by polynomial equation. By using this polynomial equation, I calculated CDOM, Secchi depth values, and then I plotted the seasonal dynamics to see the trend. This figure shows the relationship between Hue Angle and CDOM. It also takes consideration various environmental factors such as wave height, chlorophyll, total suspended matter, wind speed, and sunlight. The legend shows on the right side shows the lowest and highest value of various data used in this used in this investigation to find the relationship. The relationship was expressed by a polynomial equation that you can see in the at the top. Here y indicates CDOM and x indicates Hue Angle, and the coefficient determination r square is 0.67, which is good for this kind of research, and smaller p value indicates the relationship was is statistically significant. This figure shows that the CDOM value is higher when the Hue Angle is lower. And this figure shows the relationship between Hue Angle and Secchi depth. In this figure, I also take consideration various environmental factors like I did before, and the relationship between Hue Angle and Secchi depth was expressed by a polynomial equation that you can see at the top, and the r square value was 0.518, which is good for this kind of research, and smaller p value indicates the relationship is statistically significant. This figure also shows that when the Hue Angle is lower, the Secchi depth is also lower. With the increase of Hue Angle, the Secchi depth is also being increased. So by using the equation that I showed in the previous slide, I calculated CDOM and Secchi depth for the data of 2023, and then I plotted the CDOM and Secchi at various stations. As I told you before that I had 23 station from where the data was collected. But for the convenience, I will show two station here. So the red circle on the plot indicates that this data was this data was the value was derived from the CDOM value was derived from the satellite data, and blue and green square indicates green square is the data was collected from in-situ data. And we can see there is no significant difference between the satellite between the data calculated from satellite images and the data calculated using the data that we got from the field. And the difference here we can see because there was mismatch between the time of the data collection, the time of the satellite data collection, and the time of the field data collection. If we collect the satellite data, and the in-situ data at the same time, there will be much more similarity between the field data and the satellite data. So this is the trend we can see in the CDOM values over the time at station P2. In this slide, we can see there is we can see the Secchi depth and the Secchi depth level over the time at station P2. This red circle also shows the satellite Secchi, which was calculated from the satellite image satellite data using the polynomial equation that we derived. And the green circle was the green circle is the in-situ data. So we can see there is only three set in-situ data that was collected between May and September, and we can see there is much more data that we can calculate using the satellite data. And here we can see the CDOM levels over time at station P51. And there is only data plotted that is collected from the satellite images. So this also tells us that when there is a place where the in-situ data collection is not possible, or the data is in a remote area which is not accessible for collecting in-situ data, we can use this algorithm to collect the CDOM values and CDOM values using the satellite data, or using the algorithm, using the developed algorithm. This is this figure shows the Secchi level over time at station P51. P51, and this is also tells us that even if we do not have access to collect in-situ data, we can still measure the Secchi depth using the algorithm, using the developed algorithm, and we can analyze the Secchi depth over across the region. And as the in-situ Secchi depth data being collected very infrequently, so using the satellite data which has higher temporal resolution, we can use this data to monitor water quality frequently. So we can see there is a direct relationship between Secchi depth and Hue Angle, and between CDOM levels and Hue Angle in the water. And the higher Secchi values indicate the water is more transparent, and bluish water more transparent. And conversely, the lower Secchi values correspond the water is more brownish, and which can indicate that there is higher CDOM. An increase in CDOM levels decrease the Hue Angle, which represent the less transparent water, and lower CDOM value correlated with higher Hue Angle values. The Hue Angle approaches utilizes all the available spectral bands, and offering more complex, more complete analysis than traditional algorithm, a traditional band algorithm. So we can use a spectral band or remote sensing technology to monitor the water quality. And the advantages of satellite data is it enables more extensive and dynamic seasonal monitoring than traditional method, and it provides a broader perspective in water quality water quality variation. So that's all about my study, and thank you so much for listening. If you have any question, then feel free to ask. I will be happy to answer.